Today we will be looking at the mechanism behind generators. Let's consider a primitive generator that consists of just a loop of wire and two permanent magnets. These two permanent magnets will create a uniform magnetic field with field lines going from north to south. If we start rotating the coil, we know from Faraday that there will be an induced voltage across the loop. It's this law of induction that are the primary mechanism behind generators. This induced voltage is equal to the change in flux with a minus sign beforehand due to Lenz's law. Flux is the number of field lines passing through a surface. As we're dealing with a uniform field, the flux can be calculated as B times A times cosine to the angle between B and A. And B is the magnetic flux vector and A is the area vector to the surface. To understand what is happening when we start rotating the loop, let's look at this sketch graph. The first function is the flux at 5 different positions. The second is the change in flux, and the third is the induced voltage. What one might remark is that at position 1 the flux is at its maximum and the induced voltage is at its minimum. And that can seem quite counterintuitive when we're looking at it visually. If we're in position 1, it will mean that we are placing the surface perpendicular to the magnetic field. And we can see that all 6 field lines are passing through the surface. If we then go to position 2, which is the same as holding the loop parallel to the field lines, we have no flux, but we have maximum amount of EMF. How can that be? The key is to remember that we are to look specifically at the position of the surface area vector. In the first position, the surface is perpendicular to the field, but the area vector is parallel to it. So using the equation for the flux, we have to take cosine to 0 degrees, which is 1. Therefore, the flux is B times A. If we rotate the surface 45 degrees, the area vector will also be 45 degrees apart from the field. And cosine to 45 is 0.707. If we rotate it 45 degrees once more, the area vector is now 90 degrees away from the field. And if we rotate it 45 degrees again, the area vector will be 135 degrees away. And if we look at these cosine calculations, we see that even though we keep rotating with the same amount all the time, the change in flux is greater going from a horizontal position than from a vertical. So this is why the EMF is at its highest at this point. We also remark that the curve is AC. To understand this, we have to remember the minus sign. It's represented on the cardboard with plus at one side of the surface and minus on the other side. So when the surface is flipped, we'll see the same flux and EMF with just reverse polarity.